at this example number 8. So it has us set up to solve for this equation here. And as you can see, it's set up with a log function, and it's only a log function on one side. If it was a log function base 3 on both sides, according to what last class was, we could cancel those out and just set up an equation very simple with the arguments. However, there is only log on one side. So what we have to do is we have to get rid of that log function in order to make this work, because the argument of the log is containing the variable. We can't solve this until we do something different than just regular algebra, okay? So in last class we talked about how you convert out of log function and into exponential. And the idea was, and I didn't show you this, but we've done this before, it was called a fishhook method, which means you do something like this. You kind of create a fishhook. You circle the base, you go around the answer, and you point the arrow to your argument. And you follow that path. So it's 3 is the base. You go around the answer, which is 2. That's the exponent. And then you set it equal to 4x minus 7, which is your argument. And now what we've done is we've not only got rid of the log function, but now we've created an equation that we can solve. And the first step of the solving this equation is figure out what 3 squared is. Get rid of the exponent, right? And so what is 3 squared? 9. And we just use normal algebra in order to solve this. And you're left with x equals 4. Again, with log functions, if there's a log on both sides, then you can cancel. If there's a log on one side, then you've got to fish hook or convert it to exponential, okay, and solve. So we see another example here. Same scenario here. This is a little bit trickier, but it can still be done. Again, we can't solve a variable with a log base of x. You can't do that. So we're going to use a fish hook again. X squared equals 64. And you could do one of two things here. Some of you guys might just say, okay, what number squared is 64? And if you know your times tables pretty well, you know that the number is 8. Or if you want, you can say, you know what? I need something raised to the square power. It's kind of it looks the same, actually. And so you see something like that. But it's the same concept. Is what number times itself equals 64? It's 8, and that's your answer. Yes, Daniel?
Are you getting x squared because it's equal to 2? The whole equation is equal
Yes,
to 2? So
exactly.
equal to 3 would be x cubed.
That's exactly right. Log function sets up perfectly to where your answer, the number all by itself, is the exponent of the base. Always. And that's how it fits there. All right? All right. That concludes kind of what we talked about last class. So let's go ahead and look at transformations. With saying transformations, guys, I do have to say that you guys did a really good job on the quiz with answering the transformation problems. Filled it in really well, which I hope that kind of transitions to what we're doing here as well on this. So as you notice, when we did exponential, guys, you had to give the two little critical x values, which was 0, 1. Those were the two x values you used on the quiz. You plugged in 0, 1 in for x, and you got always the y value is 1, and 1 plugged in is whatever the base is. So if the base was 3 to the x power, well, 3 to the first power is 3. And then you did your transformations from there. Y'all remember the table y'all did in the quiz? This is going to look very similar to that. However, you got to know this. Log functions and exponential functions are inverse of each other. Okay? So you're going to start seeing some very similar stuff, except now instead of it being horizontal axis asymptote, instead of a horizontal asymptote, it's going to be a vertical asymptote. Everything is going to be flipped 90 degrees, or rotated 90 degrees, okay? So we go through and look at here. So log base 2 of x. Well, we go ahead and if we substitute in right here, if we kind of do that, let me ask you the question. Log or 2 raised to what power gives you negative 2? Negative 1. Be careful. And I'm glad y'all are answering this because I need to do this. Because 2 to the negative 1 is what, guys? 1/2. So nice try. It's an attempt. Negative 1 is exactly what would be a popular answer for sure. What power do I raise 2 to get negative 2? What? Just 1? Okay, 2 to the first power. What's 2 to the first power is 2.
Is it 1/2?
1/2? Okay, I'm glad you brought that one up too because we had to do that because that was on the quiz. Or it's actually looked at on our work, I think. That's actually the square root of 2. And we need to know these. So I'm glad you're saying these. So please, is there any other answer? What do I raise 2 up to get to negative 2? What? Tyson? Say something. Think about it. What can I raise any number up to get a negative number? You cannot raise anything to a power to get a negative number. I can't take 2 and raise it up to get negative 2. There's nothing. Okay? So the answer is kind of tricky because the answer is there's no answer. However, I did want you guys to give me attempts because I want you guys to see what these exponents are, especially the 1/2. I think we briefly talked about it last class, but we really didn't go into much detail. That's what I wanted y'all to see on that one, okay? So be careful with negative 1, though, okay? What can I raise negative 1 up? What power can I raise negative 1 up to get negative 1? Still nothing, again. I mean, granted, you're right. You could do, oh, I'm sorry. We'd have to raise 2 up to get negative 1. I'm sorry, my apology. What do you have to raise 2 up? What power to get negative 1? Well, you can't do anything. How about 0? 2 raised to the what power equals 0? 2 to the first power equals 2. 0, 2 raised to the 0 power is 1. So this actually, again, becomes no solution. I promise you that's the last one, guys. Okay, after this, there'll be answers, okay? So now 2 raised to what power gives you 1?
0.
There we go. 2 raised to what power gives you 2? 1. So as you can see here, we have a whole bunch of errors until we get to the x value of 0 and the x value of 1. If you looked on the exponents, guys, we gave you the x values of 0 and 1, and you came up with 1, 2, right? So as you can see here with this, do we do that right? Do we do that right? 2. Hang on. Sorry, guys. I think I am 2. Is what? Log base 2 of negative 2. Yeah, we did that right. Okay, just making sure because that's 1 in there. Okay, plugging it in. All right. So here's our 2 points. We can only graph 2 points, right? 0, 1, and 1, 2. Y'all agree? So 0, 1, and 1, 2. Okay, so we have something like this. However, we do have some zeros. We do have some errors. What did we establish the fact is, I noticed that I cannot raise a log to any power and get what type of number? Negative? Exactly. We couldn't get negative answers, could we? What else could we not get? 0. So guess where our asymptote is? So we're looking at, and it's actually x. It's actually x. So we have 0. So what you're looking at is something like this. It's a vertical asymptote. Why would it not be on 0? That's a good question because if you look at, we do have 0 right here. 0 does exist. So the asymptote can't be there. So the asymptote's going to be at 1, or negative 1. So if we follow this, and if y'all remember from exponentials, we had something that looked like something like that, right? However, what we're dealing with is, and I said everything turns 90 degrees, right? So now what you're looking at is something like that. And that goes down like that. And so what you see here is kind of the same thing as an exponential, but it's turned to its side. And so we go along and we ask, what are some critical points here, or our x-intercept? Well, it's where y equals 0. Well, do we have an x-intercept at all? No, we don't. The asymptote is x equals -1. Domain. Domain is going to be what the range was on exponentials. Y'all remember the range? We said that y is greater than whatever the asymptote is, or y is less than whatever the asymptote is. Well, same as here. That's the new domain. So now you say x is greater than whatever the asymptote is. And then we go ahead and talk about the range. The range is going to be what? Well, what was the domain of the exponentials? All real numbers. And then finally, to go ahead and finish it off, is this graph increasing or decreasing? Well, going from left to right, is it going up or down? It's increasing. Right, so the good news is there's not a lot of space in this next box to talk about transformations, so I won't get very lengthy in what I need to say. So we've kind of briefly talked about it in exponentials, but your a value, if it's greater than 1, then you're looking at a vertical stretch. If it is in between 0 and 1, or a fraction, vertical compression. And then, of course, if you talk about the sign of it, and I guess I should do this, guys, sorry, make it an absolute value. We're not concentrating on the sign when we're talking about compression or stretch, guys. We're not worried about the sign. We're only worried about the value of it, okay? Then let's talk about the sign. Well, if it's less than 0, it is flipped, right? Flipped over x-axis. Let's get into B. And B is going to kind of be a repeat of whatever A is. Except now it's dealing with horizontal. Horizontal stretch. Fits in between 0 and 1. Horizontal compression. And then if it is, again, B is less than 0, it's flipped over y-axis, sorry. Y-axis. Okay, and then we finish off with the two last ones. So what you see is C and D. What's C, guys? Good. If it is plus, we shift to the left, right? If it's minus, we shift to the right. D. Plus is up, minus is down.